So expectation maximization model. In clustering, if you remember, in K means clustering, what you used to do, uh, you were given certain points, suppose, and you want to make some two clusters out of it. Okay. So what did you do was initially you started with a particular point. Suppose you took a point 4 and 12. And what did you do? You went along and saw this 2 is near 4 or is this 2 near 12, है ना? So what do? You just saw the distance between this a particular point to the centroid, isn't it? So 4 and 12 are two centroids of yours, and you are just seeing whether this 2 is near this centroid or this centroid, and accordingly you just put them in a particular cluster. So if 2 is near 4 and it is not near 12, what you do is you'll include 2 into this cluster wherein 4 is there. Then you pick up the next one, and again you see the difference between 3 and 4 and 3 and 12, and you find that 3 is near 4. So what you do, you put it into the first cluster. हाँ, इसी तरह से you go about 20, you go and see 20, is it near 4 or is it near 12? You see that it is near 12, so you put it in a different cluster. Okay. So what happens here is, gradually what you will see is, once you put a cluster, then what you do, you just see a average. Whatever is in that cluster, you see an average, and then you again just repeat the step and see whether this 2 is near 3 or 2 is near 18. Hmm? Then again you find the average. The new average is 5 and 20, and then you see whether 2 is near 5 or 2 is near 20. Whatever points come in the cluster, you're again and again finding the average of it. So what happens over the time, so you start off with some arbitrary numbers, and gradually as you move ahead, you just see that all these points happen to converge as new averages. You are finding new centroids get identified, and at the end, at one point in time, it would happen that there will be no shift in the centroids. So you are having this 7 एंड 25. अब जो ये प्रोसेस आप कर रहे हैं, तो 7 और 25 ही रहेगा, चेंज नहीं होगा. अब कितनी भी बार आप रिपीट करेंगे इस प्रोसेस को, तो भी वो 7 और 25 ही रहेगा. तो एक पॉइंट के टाइम के बाद ये जो सेंट्रॉइड्स है, दे गेट फिक्स्ड. Okay. So similarly, in this case also, in EM also, in expectation maximization model that we are seeing, expectation maximization model, what we do is we find probability. हाँ, तो इनिशियली वी गिव आर्बिट्ररी कुछ प्रोबेबिलिटी दे देते हैं हम लोग, and then we just see whether the points are coming around which, and readjust the probabilities, and at one point in time what would happen, the probability will not change, so you fix it up. This is what you do in EM model. So you start off with some initially arbitrary value. You start off, you do an expectation step, and then you do an maximization step and see whether there is a convergence or not. If there is no convergence, you go back to the expectation step, do the maximization step, come and see whether convergence has happened. Convergence, what do you mean by convergence? Convergence is that the probability of the difference is not there. Probability difference is not very much. There is a very small probability difference. Okay. Convergence means that the value matches our expectations. Okay. And if they don't match the expectation, you go to the E step, go to the M step, and keep doing it till there is a convergence, and at a particular point in time the probabilities will not change, and then you stop. So how do you go about it? What is the idea behind all of this? See, any data that is coming in, what do, you try to fix a probability distribution to it, कि भी normal distribution है, exponential distribution है, किस तरीके का data है. So probability distribution estimate is basically the construction of a estimate based on a observed data. It involves selecting a probability distribution function and the parameters of that function that best explain the joint probabilities of the observed data. So whatever is the observed data, you try to just fix a probability distribution to it. Okay. And now here in EM algorithm, you are looking at likelihood. Likelihood refers to finding the optimum value of the distribution given a bunch of observed measurements. Certain observed measurements are given to you, and we are just finding out the optimal value. Now, what is maximum likelihood estimate? Maximum likelihood estimation provides the parameter values that makes the observed sample the most likely sample among all the possible samples. So you are finding out the maximum likelihood estimate. What exactly this is, we'll just go to the next slides and understand how to find the likelihood. Okay. Now, the goal of maximum likelihood is to find out the optimal way to fit a distribution to the data. Whatever data is there, how do you fit the distribution to the data? That is what is the goal of maximum likelihood. So there are various distributions. There are a lot of different distributions for different types of data: normal, exponential, gamma distribution. But the reason you want to fit a distribution to your data is it can be easier to work with it, and it is also more general. It applies to every once it becomes more general, you can apply it to various experiments of the same type. Okay, so what are we doing in EM is something called a soft clustering. So in K means you did not see soft clustering, but here we are seeing a soft clustering. What does that mean? So, in statistics, what happens is in statistical modeling, a common problem arises as to find the joint probability distribution of a data set. A maximum likelihood estimation is the method of estimating parameters of a probability distribution by maximizing the likelihood function in order to make observed data most probable for the statistical model. It assumes that all the variables relevant to the model are already fully observed. As you can see that over here we are having observed measurements. So what is maximum likelihood assuming? It is assuming that all the variables relevant to the model are already fully observed and are already present. But actually what happens, many variables are hidden. Many variables are hidden and they may not be known to you, and they may cause certain inconsistencies. And the presence of these hidden variables, also called the latent variables, in conventional maximum likelihood estimator may not work as expected. Thus, what happens is, so one, one such approach to finding model parameters in the presence of latent variable is the EM algorithm. So, EM algorithm is a approach wherein we are able to find an estimate with in the presence of a latent variable. Certain hidden variables are there, and still it finds out the estimate. EM algorithm used to find the local likelihood parameter. So it is definitely using the EM algorithm that we are using is going to use the local likelihood parameter of an statistical model. In case the latent variables are present, data is missing or incomplete. Okay, so it will help us do that even if data is missing. So we only don't go by likelihood, we use the likelihood, and then we do a maximization process to it. Okay, so we'll just see an example for it. So in soft clustering, what happens is, assumes that each instance is given a, normally clustering, the k-means clustering that you see, the clustering typically assumes that each instance is belonging to a particular one cluster. It does not allow uncertainty in class membership or for an instance to belong to more than one class. But soft clustering gives probabilities that an instance belongs to each of the set. So it is giving a probability. There is 60% probability that it will be coming from A or it will be coming from B. Each instance is assigned a probability distribution across the set of discovered probabilities. Algorithm optimizes a probabilistic model criterion. A soft clustering is usually done by EM algorithm, gives a soft variant to the k-means algorithm, assumes that there are k clusters, assumes a probabilistic model of categories to allow computing. Okay, so we'll just look at an example of it. So the EM algorithm provides a general approach to learning in presence of unobserved variables. So in maximum likelihood, what happens? There should not be any unobserved variables. It will not work well. In EM algorithm, even if we are having some unobserved variables, it will work fine. So iterative method to learning probabilistic categorization model from unsupervised data. So there is data that is coming in which is not labeled. You are iteratively running a certain process to find categories out of it. Initially, we are assuming a random assignment. So initially, you are assuming, जैसे K means में you assume up averages, you are assuming certain probabilities initially, and learn an initial probabilistic model by estimating model parameters theta, and you keep on changing this theta value. Okay, so expectation step, so there is an E step and there is an M step. What is the E step? It happens to uh, use the likelihood. It uses this likelihood. It estimates. It calculates the new probabilities, and then maximization happens to see whether it has it's compared the previous assumption to the new one and just readjusts it again. So as we start, we put in the data, unlabeled, unsupervised data over here. You have certain probabilities assigned arbitrarily. कुछ भी centroids are taken. The similarly, some arbitrary probabilities are assigned. You go to the E step, you go to the M step, and you see whether it is converging or not. If it is not converging, you go to E and M step again and again. Keep on doing this till the probabilities converge, and then you stop. So, applications is filling up the missing data in samples, discovering various hidden variables. There are a Markov model in which it helps estimating the parameters. Unsupervised learning, definitely. And in semi-supervised learning also. Semi-supervised matlab jahan ki pehle some classification is done and some also unclassified data is there. So that is what is semi-supervised classification. So let's see an example over here. Suppose you have got two coins, A and B, each with a certain bias of landing heads. So A and B are having some bias, matlab it is not a fair coin. Okay. So what is the probability of A coin landing head is theta A, and probability of B coin landing head is theta B. So we are taking some initial parameter, initial probabilities of both the coins. Okay, and we are doing certain experiment. Okay, so there are two coins A and B. One is more likely to get heads, another is less likely to get heads. So what we do is you pick up at random and toss the coins, and which one was it you want to find out. You are tossing the coin, you don't know which one was it, A or B, and now you want to find out, depending upon the pattern in which heads have occurred, whether they came from A or B. So if you're actually tossing a coin, so you have got, okay, probability of getting heads with C1 is theta 1. Probability of the second coin getting a head is theta 2. So let's do some trials on it. Okay. So let's see this experiment. We choose 5 times one of the coins. दोनों में से coin में से एक choose करते हैं. Suppose कीजिए कि अभी हमें मालूम है ये coins कौन से. We know all these coins. We are picking up a B coin and tossing it 10 times. And what are the heads or tails coming? We are recording. And what are we interested in? We are interested in the number of heads coming. Okay. So now we are tossing these coins 10 times और 5 times इनको एक एक को हमने लिया है और हमें मालूम है कि कौन सा है. तो अभी आपको आप प्रोबेबिलिटी कैसे फाइंड करते हैं? थीटा 1 यानी प्रोबेबिलिटी ए का एच लैंड करने का प्रोबेबिलिटी क्या होगा? क्या करेंगे आप? नंबर ऑफ हेड्स कितने आए? यहाँ जैसे 5 हेड्स आए और 5 बार आपने टॉस किया है ना, 10 बार टॉस किया, तो 5/10. इधर क्या है? हाउ मेनी टाइम्स? 4, 9 टाइम्स. ओके, 9/10. दिस इज द प्रोबेबिलिटी इन दिस पर्टिकुलर ट्रायल. इस तरह से आपने आप प्रोबेबिलिटी आपको फाइंड कर लोगे आपकी ए की क्या प्रोबेबिलिटी है हेड्स आने की और बी की क्या प्रोबेबिलिटी है हेड्स आने की. ओके, so suppose if you did this experiment, you have noted down how many times head has come. So blue color is the B coin, A is this orange colored coins, and you have just noted this down. So now what we did is total how many times head came when A was there? 24 times. How many times tail came? 6 times for coin A. Now for coin B, how many times did head come? 9 times. And for coin B, how many times did tail come? 11 times. So what is theta 1? The probability that coin A is going to land heads. कैसे फाइंड करेंगे? 24 टाइम्स हेड आया और टोटल टाइम्स कितनी बार आपने टोटल कितना टाइम्स है? 24 + 6. So this is how you get the probability of coin A landing heads. Agreed everyone? Similarly, theta 2 is coin B landing heads. How many times heads have come? 9 times heads have come. So head 9 divided by 9 plus 11. You get this. So this is how you get the probability. Okay. Now what are we saying is, we do not know which coin it is. A या B में से कौन सा coin है पता नहीं है, मगर we are doing this experiment. So this is hidden from you. कि which is the coin? Whether it is A coin or B coin, that is hidden to you, with you. And you are doing this experiment. And now you want to just find out the cluster, isn't it? You want to find out what is the probability of it being one coin and it being the other coin. Okay. So we do not know the identities of the coin used by each set of tosses, and we treat them as hidden variables. So how does it look like? This very complicated looking diagram is not that complicated. We'll just look at it one by one. So initially first step है, फिर second step करना है आपको. I'll just take a pointer maybe. Okay, this is the first step. Initially what we do is we give certain probabilities to it landing A or B. Some assumption. हमने ये ले लिया कि कॉइन A का हेड आने का probability है 0.6 और कॉइन B का हेड आने का probability है 0.5. You can take any number. Okay. Now we are doing this experiment. Now we do not know which coin are they. ए बी में से कौन से कॉइन को टॉस किया है, तो ये स्ट्रिंग आई है, आपको मालूम नहीं है. तो नाउ व्हाट यू डू इज यू डू एन एक्सपेक्टेशन स्टेप. एक्सपेक्टेशन स्टेप में आप क्या कर रहे हैं? एक्सपेक्टेशन में क्या कर रहे हैं? यू फाइंडिंग आउट द लाइकलीहुड एंड देन यू नॉर्मलाइजिंग इट एंड देन यू गेट दिस नंबर 45. Okay, so initially that you know this is the probability 0.6 for A, you find out the likelihood for A and then normalize it to get this value 0.45. Okay, and multiply it. Okay, so how did you really get it? जो ये जो number आपको मिलेगा वो यहाँ हमने लिखा है. Okay, so let's see these steps. So once you do the expectation step, you find the likelihood, you normalize, you get this particular table, and then you get the total of heads from A, heads from tails, and then you find out the new probabilities. नई probabilities find कर रहे हैं और उसके बाद ये 0.6 जो probability A का है उसकी जगह पर 0.7 आ जाएगा और यहाँ जो है 0.58 आ जाएगा. तो अब ये पूरा का पूरा स्टेप इस न्यू प्रोबेबिलिटीज जो हैं ये वाली उनसे आप करेंगे. आप जब ये रिपीट करते रहेंगे पूरे स्टेप्स, एक टाइम के बाद ऐसा होगा कि यू विल द प्रोबेबिलिटीज विल कॉन्वर्ज एंड दे विल नॉट चेंज. So after they converge and they do not change or minor change is there only, then you say that this is the probability of A coming head and this is the probability of B coming head. Okay, so this is how EM algorithm works. So let's see the steps one by one. Step one is what? You start off with taking a probability, initial probabilities for first coin landing heads and the second coin landing heads. You take a certain probabilities here. Then what is the next step? You do the experiment. Now you have done this experiment wherein head has come 5 times and tail has come 5 times. Then what you do? You find out the likelihood and then normalize. So first you find out the likelihood of how do you compute likelihood? We'll compute likelihood using binomial distribution. Why binomial? Because here we are tossing a coin and we are getting a success that is head is coming and failure that is head is not coming. So binomial, if you remember, it is probability of theta is the probability of success coming. 1 minus theta is probability of failure. And how many times have we tossed is k and the total number of times is n. Okay, so if in the first round you have got 5 heads and 5 tails, the likelihood of A is what? Probability of A was 0.6 raised to 5 times head has come and 1 minus theta. Okay, 1 minus theta means 1 minus 0.6 raised to total number of times you have tossed the coin is 10 and how many times head has come is 5. So this is how you get the likelihood. Similarly, you find out the likelihood for B also. likelihood for B can be found out. What is the probability of B coming? 0.5. How many times has head comes? 5 times. And then 1 minus 0.5. So this is how you get the likelihood. Once you get the likelihoods, what you do is you normalize it. Normalize it means you take these values. Okay. So you have taken the likelihood values, this and this value. This has come as a numerator, and this plus this will come as a denominator here. So now you're getting a value 0.45. This is what is the number that you're going to multiply it. Okay, आप देखें तो यहाँ ये जो number आया था आपको 0.45 and 0.55. You can see over here 0.45 and 0.55. Okay, these are the numbers that they have come. So here you are going to find the likelihood and then normalize to get this value. So how did you get this 0.22, 0.2 over here? After multiplying by 0.45 you get this values, but how you're getting it we'll just see in the next slide. इसी तरह से 0.55 से मल्टीप्लाई करके आपको ये वैल्यूज में किससे मल्टीप्लाई किया है आपने? लेट्स लुक इनटू इट. So I hope you understood how you got 45, 0.45 and 0.55. How did we get this? Initially we had certain probabilities assigned. वो जो probabilities assigned हैं उसको लेकर हमने likelihood find किया. 0.6, 0.5 उसको लेके हमने likelihood find किया. उसके बाद we did this normalization wherein A divided by A plus B. What is A? This value divided by A plus B. ये value और ये value को denominator में रखा है. That is how you got 0.45. Similarly, you go about doing for B also. Now, repeat the process for all the experiments. So this is to be done for all the experiments. जितने भी experiments, 5 experiment है, पांचों के लिए आपको इस तरह से करना है. Same thing. Okay. Then all of them you take. Now how did we get these values? No, 0.22. A 0.2 heads, 0.2, 2.2 and 2.2. Where did we get it from? 0.45 को आपको मल्टीप्लाई करना है कितने नंबर ऑफ हेड्स आए थे. तो पहले केस में आप देखें तो कितने नंबर ऑफ हेड्स थे? 5 हेड्स थे. ऐसे ही 5 टेल्स थी, राइट? तो 5 हेड से मल्टीप्लाई किया 0.45 को, सो यू गेट 2.2. सिमिलरली 5 टेल्स को मल्टीप्लाई किया आपने 0.45 से. ये क्या है? 0.45 ए के लिए ए की नॉर्मलाइज्ड वैल्यू है likelihood की. ठीक है, so you are multiplying for A and then you are getting 0.22 and 2.2. ठीक है. Similarly for B also 0.55 को आपने number of heads और number of tails के साथ multiply किया है, so you are getting 2.8, 2.8. And this is going to be done for all the 5 runs. When you do this for the 5 runs, what happens? You get these values over here. ये जो values आपको मिल रही हैं, ये वैल्यूज आपको वो कैलकुलेशन से मिल रही है. अब आप सोचिए कि ये तमाम जो आपने सिर्फ एक के लिए किया है, अब आपको ये बाकी के लिए भी करना है. ये सभी वैल्यूज आपको पता करनी है. एंड देन नाउ यू हैव टू टोटल इट अप. ये जो आपको पूरा बॉक्स मिल रहा है उससे आपको टोटल करना है टू फाइंड आउट द न्यू प्रोबेबिलिटीज. सो व्हाट आर वी गोइंग टू डू हियर? 21.3 is the probability of heads. And total probability is 20, total number is what? How many times the head is going to come? Estimate क्या हुआ है हमारा? 21.3 plus 8.6. So denominator में 21.3 plus 8.6 आया और ऊपर number of heads कितना estimated है इनको मिलने वाला है वो आया expected. Okay, so this is complete the expectation step. Now we are finding out the new probabilities. So this is what is the maximization step. Okay, so you found out this table, you found out the total number of heads and total number of tails for coin A and coin B. Now with the new values, after the expectation step that you have done, you have to go for doing the maximization step. And in that what we do? We just do this part. 21.3 divided by the total of this. So now the new probability of A landing heads is 0.71 and for B landing heads is 0.58. Okay, so now what is being maximized here? The parameter theta is being maximized over here. Now what you do is go and feed in this over here. Means क्या हो रहा है? ये जो 0.71 नई probability मिली है एक की हेड आने की, वो आपने इसमें ये पूरे सिस्टम में दोबारा से फीड किया, पूरा का पूरा प्रोसेस दोबारा से आपको करना है. इनिशियली आपने कैसे शुरू किया था? What did we you start from? Initially the probability of A coming heads was zero point 0.6. You have assumed it, okay? And for B coming heads, you had assumed it to be zero point 0.5. Now when you did this experiment, what you got was new experiment showed you certain values of head and tail. उसमें से आपने कुछ probabilities को converge किया है. So here we are finding out the new probabilities depending upon this particular experiment that we did. The new probability is 0.71 and 0.58. So now we are going to feed in this system the new probabilities that you've got. Okay. So here we are feeding in the new probabilities and doing the same step again. Now you can see that how long is this complete process. So it is a very expensive process to do. It will take a lot of time to converge, in fact. So when you keep doing this, what will happen? At one point in time, what will happen? These probabilities will not change, or maybe change for very slightly change. Huh? So what you do? You then fix it up. Then you say that the probability of A landing heads is 0.80 and probability of B landing heads is 0.52. So, जैसे K means में you have those clusters centroid converging after a point, you have this converging after सब वेरियस स्टेप्स ऑफ ई एन एम कॉन्स्टेंटली करते करते आप कन्वर्ज करेंगे. ओके, तो रिपीट द प्रोसेस अंटिल यू गेट द सेम प्रोबेबिलिटी अगेन. In our case, this is the probability that you get again and again, and thus you stop the process, iterative process. This estimation, what are we doing is we are taking some data, huh? We're feeding it that data into the machine and then classifying the data into some classes. Maximization is whatever we estimate, we have to now maximize it. Now, from given data, EM actually learns a theory which tells that what each example to be classified, how each example is to be classified, and how to predict and the feature value of each class. For this, it starts from a random classified data and repeats the two steps until a clear result is formed. So this is what is the EM algorithm. So the EM algorithm is very, very slow, even on the fastest computer. It works best when you only have a small percentage of missing data. तो लेटेंट डेटा के बारे में ये काम कर रहा है, तो बहुत स्मॉल परसेंट ऑफ मिसिंग डेटा है तब तो ठीक है, इट्स वेरी टू स्मॉल. द डायमेंशनैलिटी ऑफ द डेटा इजंट टू बिग, only then it works very fine. The higher the dimensionality, the slower the E process. The expectation process will be very slow. And for data with larger dimensionality, means you have got various attributes, you may find the E step run extremely slow as the procedure approaches a local maximum. So it's very, very slow.